Alright, so I think I'm recording. We're taking a look at Skill Packet 5, which is exponential functions and logarithmic functions. And here in this Skill 5G, in the previous homework assignment and in this homework assignment, we're solving equations. And we need to know the properties of logarithms to solve these equations, and also just the definition of a logarithm itself. Let's take a look at this problem number 1. On the left-hand side, we have a base raised to a power. That exponent contains our variable. We don't have any way to isolate that x when it's an exponent. We need that exponent to be down as multiplication, so that's where the logs kick in. If we take the natural log or the common log of each side, then we'll be able to use properties of logarithms to get the x by itself, and then use a calculator to approximate our answer. Because the buttons on a scientific calculator are a log button, a common log button, which is base 10, and a natural log button, ln, which is base e. So and it doesn't matter which we use, natural log or common log. Let's use the common log. If I take the log of each side, I've got the log of this base raised to x plus 1. And since I took the log of the left-hand side of the equation, I'm going to take the log of the right-hand side of the equation. Alright, so now by the power rule, this x plus 1, this exponent of x plus 1, I can bring it down as a coefficient in front of the log. So I've got x plus 1. Here's a factor times another factor. So now I have an equation where I can begin to attempt to get the variable by itself, because on the left-hand side, I have two factors, and right now the factor of interest contains that variable x, that first factor x plus 1. I need to get it by itself, so I need to divide both sides of this equation by the log of 2/3. By dividing on the left-hand side, these common factors divide to 1. We say they cancel each other. So I have to divide the right-hand side of the equation to balance the equation. So now I have that factor that contained my variable by itself, and I can subtract 1 from each side and have my answer. So this is an exact answer. Many times they'll ask us just for the exact answer, or they may say to approximate this to some number of decimal points. I don't know if the directions I didn't copy. I can't remember if it says that. On one of them it did. Yeah, to 3 decimals. Okay, so let's jump in, pull in the calculator, go back to my problem where I can see what I've got. So I've got this logarithm of 5 over 12. Now you must close your parenthesis there, and then divided by the log of 2/3. And it's it's forgiving for this last parenthesis, but I do it out of habit. All right, so I didn't have my calculator round to 3 decimals for me. I mean, I could do that, but it's just, hey, let the calculator do the work. All right, 1.159. All right, so the exact answer, the approximation. All right, so let's go on to the next one here. Here we have an equation. See, the last time it was an exponential equation, and this time it's a log equation. And we have on the left-hand side 2 logarithms, a log plus a log. That's how they got 2 log. And on the right-hand side, just a logarithm. Well, both contain my variable. We know that exponential functions and log functions are one-to-one functions. So if we can get this equation where we have log equal to a log, they could just set the arguments equal to each other. So that by the power rule, this coefficient of 2 can be pulled up as an exponent. And now I have two logs that have the same base that are set equal to each other. Well, like I say, because these are one-to-one functions and they have the same base, then and the numbers are the same, these arguments, this x squared has to be the same thing as x plus 6. Okay, that's a quadratic equation. You've been solving quadratic equation for years in practically all of your math classes, at least here at Northview. Let's get this in standard form. In standard form for a quadratic equation, ax squared plus bx plus c equals 0. So from here, we can try to determine if this trinomial can be factored. If it can, it's generally the easiest way to solve this. If it cannot, we can complete the square or use the quadratic formula. So we should be able to see that it does factor pretty easily with a constant term of negative value here and the middle term being negative. I'm going to have one negative value, one positive value, and the larger one in magnitude is going to be negative. So with 6, it's such a small number that we've only got 1 and 6 and 2 and 3 to try. So I'm going to have x minus 3 and x plus 2. And that should work. Now, we have a zero product theorem that says if you have two numbers that multiply together to give you 0, then either one or both of the numbers must be 0. So either x minus 3 equals 0, which would give us a solution that x equals 3, or x equals negative 2 is a solution. And remember that these are just possible solutions to the original equation. We need to plug them in and check. We can't take the log of a negative number and we can't take the log of 0. So this negative 2, we must throw it out. It's extraneous, but the 3 is okay. We're good with that. Now, we can, since it was a common log button, it's fairly easy to check that the left-hand side is equal to the right-hand side. So if I take 2 times the log of 3 and compare that to the log of, well, 3 plus 6 is 9, you can see that they're going to be the same because that 2 can be pulled up to 3 squared, and the log of 9 equals the log of 9. So we're good on that. Now I think I'm going to do these in pairs, so I think I'm going to stop this video and do the next two on another. Hope that helps, and talk to you later.